Hello, and welcome to another episode of Earth911's Sustainability in Your Ear, the podcast conversation about accelerating the transition to a sustainable carbon neutral society. I'm your host, Mitch Ratcliffe. Thanks for joining in the conversation today. What's the most used material in the world? Well, it's cement. The basis for building most of the modern world was invented during the Roman era and remains the most used material on the planet. In 2021, cement accounted for 1.6 billion tons of carbon dioxide emissions globally, about 4.3% of all greenhouse gas generated that year. Our guest today is Grant Quasha. He is the CEO of Eco Material Technology, a New York-based maker of low-carbon cement and materials for making concrete. Eco Material Technologies has re-engineered the original Roman method of making pozzolanic cement using processed fly ash generated by industrial processes. The company uses a low-temperature process to remove carbon when making PozzoSlag, a material that can replace a significant portion of the Portland cement required to make durable concrete that can be used in buildings and bridges. The resulting concrete carries an embodied carbon footprint 95% lower than traditional Portland cement. And after hardening, pozzolanic cement is also 20% stronger than Portland cement. Eco Material Technologies operates more than 100 cement facilities in the United States, which is sufficient to scale and displace a lot of carbon-intensive concrete. In fact, a concrete made with 5% of the traditional carbon footprint would help us avoid 1.5 billion tons. That's a lot, 1.5 billion tons of CO2 emissions annually. You can learn more about Eco Material Technologies at ecomaterial.com. Ecomaterial is all one word, no space, nor dash, ecomaterial.com. Now let's get to the conversation. Welcome to the show, Grant. How are you doing today?
Good, Mitch. Thanks so much for having me.
Well, hey, you've got a fascinating story. You were at Green Cement for about 11 years where you developed this low-carbon cement technology. How did Eco Material Technologies come to be in July of 2021?
Sure. So we created Green Cement a little bit over 10 years ago, as you noted, and it was a small business that was focused on coming up with more creative solutions to what was really a looming problem that folks hadn't really focused on, which was the carbon intensity and emissions profile of Portland cement and concrete, which is about 8% of global emissions. And so we were focused on figuring out ways to enhance the effectiveness and reactivity of some materials that had traditionally been used to reduce the emissions intensity of cement and concrete, and that was fly ash. We created the business with really one location in Texas and grew that business to the point where it was ready for significant expansion. The technology was ready to go, and we were having significant success. But we had two main issues. One was we needed to raise more capital. Mm-hmm. And two was we needed to access more raw material. We needed to backward integrate into raw material because concrete and cement are two of the biggest commodities in the world. They're the biggest man-made commodities in the world, right behind water. And so we actually were able to do both those things at the same time. About 2 years ago, we raised about $800 million between equity, bringing on some new equity partners and debt, launching the first high-yield green-rated bonds in the U.S. And we acquired the largest fly ash marketing and distribution business in North America, a company called Boral Resources. We combined Green Cement with Boral Resources at that time to create the largest supplier of supplementary cementitious materials and near zero carbon green cement replacement products in North America. And we renamed it Eco Material Technologies. And that's who we are today.
Now, you were a metals and mining analyst at J.P. Morgan earlier in your career. Was that a key to seeing this industry and the opportunity to decarbonize differently?
Absolutely. My experience in my career has generally been around heavy commodities, whether that's bulk commodities like cement, concrete, or mining or metals. And one of the interesting areas that became apparent to me early on was that these industrial sectors were critically important to the global economy. And frankly, you can't really do without them. You can't do without concrete. You can't do without steel. These are fundamental building blocks of the world. But as we were able to see, obviously, the looming importance of decarbonization, folks were really focused on the power sector. Folks were obviously very focused on vehicles and those two main areas. and less focused on industrial emissions. And so, working more in those sectors, it became apparent that we were having a real opportunity where the intersection of decarbonization and infrastructure was going to be a great opportunity for growth. And so that was one of the real reasons why we became interested in pursuing this effort.
Now, a lot of people don't understand how cement and concrete are made. Can you tell us how the PozzoSlag process works and what's involved in burning away carbon in order to make this material?
Sure. So, traditionally, the way I like to talk about is that cement used to be green, then it went black, and now it's getting greener again. So it was green under the Romans. Essentially, they were using volcanic ash, quicklime, and seawater and some other recipes at the time to create the great structures that still exist today, like the Pantheon. Now, that technology was not great at large scale industrial efforts. It was good for the Roman Empire, but it took a long time to set. The reactivity was lower, and frankly, it was waiting to be disrupted. And what happened about 200 years ago was you had gentlemen in the UK create what is now called Portland cement. Mm-hmm. And that formulation is amazing because it is really one of the only industrial formulations that has lasted over 200 years, virtually unchanged, which if you look back, it'd be very difficult to find something from a technological basis that's been that powerful for that long. However, and they created a great mousetrap. They created a cement that would cure in very quick amounts of time, that would be very effective, that was easy to produce at mass amounts, but it was hugely emissions intensive. At the time, in the 1800s, no one cared about that, obviously, and no one cared for quite some time thereafter. And so what they did was they took limestone, milled it down, put it into a kiln, heated it to about 2,000 degrees centigrade, and they created what was the active ingredient in Portland cement, which is called clinker. Mm-hmm. This process is hugely emissions intensive on two fronts. One is you heat anything to 2,000 degrees centigrade, you really require fossil fuels in order to do it. Very difficult to do that with wind and solar, for example. And then the other bigger problem is that chemically, you're actually changing the material from a CaCO3 to a CaCO, which liberates a chemical molecule of CO2, and that's about 60% of the CO2 emissions associated with the creation of Portland cement, which is approximately 1 ton per 1 ton of material created.
All right, so it's interesting. So the heating is one source of carbon emissions. The freeing of that one molecule is the other. And so all of that adds up to the most carbon intensive material that we've been making. Now you're making a lot of progress. A year ago, you were able to replace about 60% of the Portland cement in the material the end material. But today you're up to 100%. What was the key to making that transition to getting that level of efficiency?
Yeah, so the approach that we're taking, obviously, is there's two main approaches to decarbonize cement into concrete. The first approach, which is predominantly being taken by the existing cement and concrete producers, which are big companies, is to decarbonize the process itself, the Portland cement manufacturing process. And you can do that in a number of ways. You can burn more renewable fuels. You can try to capture the carbon associated with it. And you can come up with new technologies that you can put on existing plants. The way that we approach the situation is somewhat different. We are just using alternative materials that do not require heat, nor do they chemically release carbon, right? And so we create a number of products that can replace cement in concrete at various levels. So our traditional fly ash, what we call supplementary cementitious materials, are replacing cement and concrete and have been for decades at 20 to 25%. Our PozzoSlag material, which has really gained a lot of traction in the last 5 to 10 years, replaces it at 50 to 60%. And our newest product, our PozzoSem material, as you described, now replaces it at 100%. A lot of that has just been innovation, a lot of hard work from our scientists and working with our customers to develop these new products. I would say that it's also critically important that when you look at these variety of products, the life cycle into the industry is somewhat different. Those lower replacement factor products that I discussed, the 20-25%, they're actually less expensive than Portland cement. And so traditionally they were used because they were a cheaper alternative, but they also make a better material. That gap has narrowed, obviously, as their environmental benefits have become clearer. The 50 to 60% replacement product prices at the same price as Portland cement. It's meant to be a look-alike product. It prices it the same, and you get the added environmental and performance benefits. The 100% replacement product is still more expensive, significantly more expensive today than Portland cement. So today, it's still being used for more specialty applications. But over time, our view is that we are going to look to bring that cost down. And also, if one considers, frankly, the cost of carbon associated with Portland cement, and you were to look at we operate in the US and Canada for the most part, but if you were to look at a European regime where you have a approximately $100 a ton cost of carbon and added that on top of the cost to produce Portland cement, then our 100% replacement product becomes competitive.
Now, because you're using fly ash, is that already essentially the carbon is burned away for the most part, and that allows you to use a lower temperature process as well?
Correct. Yeah. So our two main sources of raw material are coal ash, which can be fly ash or bottom ash, so two different types of material that comes out of coal boilers, and natural pozzolanic materials, which is essentially volcanic ash. What these materials share in common is amorphous glass. And it's that amorphous glass that we're looking to isolate that allows us to create these higher performance materials and replace the Portland cement. Now, carbon, as you noted, is an inactive material, and the carbon is going to retard essentially what you want, which is the solidification of the concrete with your material. And so the nice thing about most of the material that we have, whether it's natural pozzolanic material, fly ash, it's usually very low in carbon, so we don't actually have to heat anything up, and we can really just use a milling process, essentially, a proprietary and patented milling process where we run the material through our own mills. And we also use our proprietary and patented chemical packages that essentially enhance the reactivity of the material. So we use zero heat.
Now, the other issue with moving concrete to a construction site is the weight and the transportation involved. Do you do this at all 100 of your facilities, or do you need to produce this and then ship it for local mixing and production? And are there opportunities to lower the emissions associated with that transportation and delivery process?
Yeah, absolutely. That's a really critical factor that a lot of people miss, is that the cement and concrete industries are extremely large, but frankly, extremely local and regional because of the fact that this material is so heavy and it's modestly low value material, right? When you consider you're paying $150 for a ton of material, that's 2,000 pounds. You have to be able to move this stuff efficiently, or the costs get completely out of control. And so what we bring to the table that a lot of, I'll say smaller players or not at scale players who are doing great work innovating and decarbonizing cement and concrete is we already have an existing logistics infrastructure that you alluded to, over 100 different sites, 50 different terminals around the country, thousands of rail cars, hundreds of trucks, and millions of tons of storage capacity to allow us to get the material from where it's produced to where it's needed. Now, that portion of the emissions profile, like you mentioned, is important. It does pale in comparison to the primary emissions associated with Portland cement. It's probably less than 1/10, for example. That said, there are important ways that we can look to reduce the emissions impact of those of that supply chain. The first of which is being closer to your markets, right? The less distance you have to move something, the better. And so we're focused on a hyper-regional growth pattern, which will allow us to do that. The second is we're also testing out with some of our partners technologies like electrified trucking, et cetera, to be able to move the material in a greener fashion. That said, when we do move the material longer distances, it's generally transported by rail or barge, which are actually very efficient ways of moving material. A lot of people don't realize how well blessed we are in this country with our inland waterway system that was created hundreds of years ago, but it's really efficient at moving, really heavy commodities long distances.
The idea of an electric cement truck is intriguing. Do you see the fleet being converted, or are we going to have to see a new generation of truck developed in order to get there?
So I think, when you mentioned the truck, I think there's going to be, I would say you're more likely to see the powder vehicles, i.e. the ones that are not ready mix, that are not the turny ones, the ones that are just moving the powder from one location to another, to be electrified first.
Okay.
And then I think, and that is, you're starting to see pilot projects of that happening. And then the ones that actually go to the job sites, right, and that will pour the cement for the concrete in your driveway, that'll probably be a bit a later adaptation, in probably the next generation. The point to point is the easiest one to replicate with an electric drivetrain first.
Grant, this is fascinating. Let's take a quick commercial break. We're going to be right back to continue the conversation. Now let's return to the discussion with Grant Quasha. He is the CEO of Eco Material Technology, and we're talking about low carbon concrete. So, Grant, what can these materials be used for? Are new kinds of construction possible using pozzolanic cement?
Yes, they are. And I mean, we can use our material today for virtually any application that you're using cement and concrete for. So in the United States, for example, about 120 million tons of cementitious material are used on an annual basis. We provide about 7 million of those tons with our supplementary cementitious material. So we're about 5% of the market. We're looking to grow that dramatically. Our material is generally first used in infrastructure. That's the largest part of the market: roads, bridges, highways, because our materials and our pozzolanic materials allow concrete to be stronger, last longer, and more resistant to the things that kill it, like chlorides and sulfides, road salt, acid rain, things like that. So the DOTs in all 50 states, to some degree, require our types of materials to go into those projects. The next other main areas: non-residential construction, residential construction, are also users of our material. But really, the most exciting growth areas, I would say, are some of the more advanced building technologies. And the one I'd like to highlight is 3D printing of homes. So we've been working with folks to 3D print homes with our 100% replacement PozzoSem green cement product. And the great thing is, not only can you make a really high quality, high R value, low cost home at similar cost to a stick build. You can do it very quickly, in sometimes as little as 3 days, to construct the frame of the home, and you can do it in a much more green fashion with our material at a reasonable cost versus what the traditional alternatives are out there. So we're really excited. It's still very early days. We're only in a handful of homes that have currently been printed, but our partners and others out there, hopefully, who will start using our material, I think there's a chance that thousands of homes per year could be printed with our material and with the 3D printing technology.
How in general is the construction industry responding to the product, and what's driving their adoption of pozzolanic cement?
So generally, I would say that there's a lot of talk about greener materials.
Mm-hmm.
People are interested, and it tends to be somewhat regional, right? And so you'll see more of this in California, and you'll see more in the Northeast. And so there's a desire for lower carbon alternatives.
Mm-hmm.
It's still a difficult time to say that there's any type of a green premium that's out there. I think people are excited and willing to embrace these technologies as long as they perform exactly as old materials did, and they're the same price or less, right? And so we do need to get to a point where people are actually willing to pay for what really is a better and more environmentally responsible material. We're not quite there yet. You are there in certain little pockets, but we want to keep pushing forward and making our material as cost effective as possible, because we don't want to have to wait for that green premium to arrive. We want to push the material first and say, listen, we can actually have you win on all three fronts: performance, cost, and environmental credibility.
Do you see any emerging regulatory requirements that might drive additional adoption?
Absolutely. So the main issue with regulatory and the regulatory environment is that it's pretty fractured across the US. Like I said, departments of transportation tend to be the main arbiters of what goes into concrete, the vast amount of concrete that goes in, to roads, bridges, and other parts of our country. They generally are very good at defining specifications. So, what shall go into this material or what shall not go into this material? And so, those are very clear, but those are designed for materials of the past and of the present, but not materials of the future in many cases. And so, what we need to do is, and we're starting to see some of this, is shift from specification toward performance. Metrics that the material must be this hard by this period of time. It must be able to withstand these tests, et cetera, et cetera. But what necessarily goes into it is not as critically important, because we know that in order to solve the massive problem associated with cement and concrete emissions, we have to have new innovative materials.
Did the bipartisan infrastructure law or the IRA provide any additional incentives for adoption of your technology?
Yes, there are some incentives in both those areas. There's some push and some pull. There's some desire, for the federal government, for example, to look toward lower carbon alternatives in building materials. We've not seen that much yet from that pull angle coming in, but we're pursuing it. And then on the push side, there's been a focus toward putting capital towards manufacturing for materials such as ours. And to be fair, we've gone and we've applied for some of these grants to help us supercharge the construction of some of our green cement facilities. We don't know the outcome of that yet. We're hopeful that we may benefit from some of those programs, which would really help us build out what we're doing that much faster and on a national level.
And so, if a construction company adopts your low carbon cement, can they earn lead points or are there other benefits for them that they can tell their customers about in order to drive perhaps even a higher price for the project they're building?
Yes, traditionally, LEED certification has been less about the raw material that's going to create the foundation and some of the parts of the building, and more about what's going on within the building itself. But we believe over time, people are going to be more focused on the raw materials that are being utilized in the building and construction industries, and programs like LEED, et cetera, will become more cognizant of materials such as ours and allow folks to get benefits associated with using our materials, which today are still modestly limited and not where we need them to be, but over time we do think will change.
Now, one of the biggest challenges across the transition, the sustainability transition, is measuring Scope 3 emissions. And since you're a supplier of materials to make a lot of different things, you are in an interesting position to provide a great deal of information to your customer about their Scope 3 emissions. Do you deliver reports, and are customers using that in order to report out to regulators and to investors?
This is an interesting area that is starting to gain a lot of traction, and we are not where we need to be yet on it, but we are getting there as an industry, as a company. And a lot of this has to do with environmental product declarations, EPDs, as they call them, for all of our materials, so that when we deliver the material to the customer, we can say, here's the associated impact with this material, et cetera, and then they can run it up, as you said, through their Scope 1, Scope 2, Scope 3 emissions assessments. And so, yes, we can and we will be providing them. That said, it's still a little bit in its early phase as far as coming up with an industry standard for some of these EPDs. But we should be there within, my view is within the next year.
Within the next year, that's very encouraging to hear.
Yes.
Now, as you've got this broad national footprint, but we're talking about a lot of the gaps still, some regulatory incentive gaps and so forth. What can we do to accelerate the adoption of low carbon concrete?
I think, as it depends on the we. I think
let's say the United States, just the U.S.
Right, the U.S., I think we can be very thoughtful about the fact that I think in general we have an enormous resource for building what we're trying to do beyond our, call it 7 million tons a year up to 20, 30, 40, 50. And that is, we have billions of tons of coal ash in the ground, which is actually an environmental problem right now. Mm-hmm. And generally, you say the word coal, and people start to say, oh, I don't want anything to do with it. And I fully understand that sentiment. That said, the government and people should not be afraid of this material. You should be afraid of it if you just go ahead and cap and close all of these landfills and just hope nothing's ever going to happen. What you should be excited about is that we can actually remove this material. And especially if we have some help from the federal government, from the state and local government, some increased incentives, we can remove this material, beneficially reuse it in concrete, and use less Portland cement. So we're going to solve two environmental problems in one. Now, the issue becomes, the EPA and the federal government and some agencies, et cetera, we can do this. And frankly, we are doing this right now. We have about half dozen of these projects that are either producing today or are in construction. And we will be producing millions of tons of this reclaimed, harvested material within the next year or so. That said, there are some limitations and some regulatory issues where if we had some better help from the government to basically acknowledge the fact that we need to take advantage of these resources and beneficiate as much of this material as possible and not put arbitrary time limits on how long, for example, an ash pit can stay open to allow us to fully beneficiate it. In some cases, for example, we look at a project and it needs, according to the EPA, to be fully cleaned out in 15 years. And if it's not, then you need to cap and close it. Many of these projects, because of their size and because of the market and the way that it works, the economics say it would take 25 years, right? And so if we have the ability to spend the proper amount of time to do the right job, everyone is going to have a better outcome. We're going to have cleaner cement and concrete, and we're going to have cleaner local communities because you won't have these giant waste dumps there anymore.
Well, you've just introduced an idea that I'm hearing more, which is that the solution to the transition is in part to go back and clean up the industrial era's waste and to mine all of that waste for the next generation of materials. As you think about this, do you imagine that we can actually clean up all the way back to 1850 the coal ash that we have produced? And do you know where all that material is so that you don't have to worry about new coal burning in order to have a sufficient supply of materials?
Yes. We, in many cases, in our predecessor businesses, actually know where that material is because we worked with the utility to put it in the landfill in the first place. And so we work closely with the utility, and our goal is to beneficiate as many tons as possible. There's a project that we have in Pennsylvania, for example, with a 2 million ton landfill. We estimate that of that 2 million tons, we will remove all of it, and every ton will be beneficially put into bridges and roads, generally in the Pennsylvania area, over the next 15 years. We're actually looking at expanding to a second facility at that same site because we know over time we're actually going to run out at the first site. So there's billions of tons of this material. It's not all the same. Some of it's really good material. Some of it's not so good material. So obviously we're going to go after the better material first. But over time, as technology evolves, we can treat more and more and more and more of this stuff. And while I don't think we're going to get every ton of the 2 billion tons that are in the ground today, I think we can get pretty close. And that, just running your rough numbers is, as you said, a couple generations worth of cement and concrete in this country, which is an absolutely fantastic outcome to think about how can we rebuild in a clean way with the waste of the past.
Is this also an opportunity for American companies to mine that material all over the world and deliver local solutions? So we're not transporting the material back and forth, but to really expand as the nation that helps clean up the planet.
Yes. And we've looked at it as well. I mean, we're obviously mainly focused in North America, but we've absolutely looked at, and we will continue to look at opportunities to take our technology for harvesting, for upgrading, for beneficiation, and for high performance materials all over the world. Today, we're probably we're closest to doing something in Europe or in Asia. But over time, we would like to partner with others to be able to expand this. This is a really big problem. And while we are a large company for what we do, we're still just one part of the solution, and we can only do so much. So we're really excited to help be a catalyst to do that elsewhere.
And in terms of high performance material, can concrete start to replace some of the other more carbon intensive materials that we use, like steel and aluminum in construction? Will we need less rebar, for instance, as a result of new technology?
It depends. I mean, my view is that you're still going to need steel, and you actually have a pretty reasonable way to mostly clean it up. And we've actually done a very good job in this country by transitioning from essentially basic oxygen furnaces, which take coking coal and iron ore and other elements and put them in a big furnace and create virgin steel. It's very emissions intensive. It's like making Portland cement. Versus mini mills or electric arc furnaces, which basically take scrap steel, recycle it with some new material in there as well. And in the US, about 80% of our steel production is actually the latter. And that is, a much less carbon intensive way to make steel than the original blast furnace. Now, globally, it's flipped. Globally, and even in Europe, there's more blast furnace production than there is steel recycling in electric arc furnaces. And that transition is occurring, although more slowly than it has in the US. Now, the nice thing about electric arc furnaces as well is that you can provide that electricity with green sources. And so you can further lower that emissions impact. Now, fundamentally, can we get rid of steel? I don't think so. The nice thing about steel and concrete are that they're basically their own best friends. Concrete is fantastic under pressure, and steel is fantastic under tension. And so concrete, you don't want to put concrete under tension without steel in it, which is why you have rebar in it. And steel, you don't want to put under massive pressure without concrete because it won't hold up to it. So that's why they work so well together. And so can we use other technologies like fiber or other types of things or nanomaterials to reduce the amount of steel that goes into concrete? Yes, we can. But I don't see fundamentally steel going away.
Grant, this is really an interesting and inspiring conversation. How can folks keep track of what Eco-Material Technology is doing?
Sure. You can go onto our website, www.ecomaterial.com, or you can go onto our other subsidiary website, which is very aptly named greencement.com. And that'll give you an update in the press areas on what we're doing. You can follow me on LinkedIn, Grant Quasha, Quasha. I always post all nice articles we get and mentions on what we're doing and growing our business. And we're starting to really see a lot of people interested. So actually, the New York Times mentioned us yesterday. So very exciting stuff, and look forward to continuing to grow what we think is a great company that is going to help. We've helped lead the industry to where it is today in some of the decarbonization, and we look to really step that up over the next 5, 10, 20 years and see what we can do.
Well, Grant, thanks so much for spending time with us. It's been fascinating.
Thank you, Mitch. Take care.
We've been speaking with Grant Quasha. He is the CEO of Eco-Material Technology, and you can learn more about their low-carbon cement and concrete materials at ecomaterial.com, ecomaterial being one word, no space, no dash, ecomaterial.com. The prospect of lowering annual CO2 emissions associated with building homes, skyscrapers, and roads by 95% is sufficiently important to justify enthusiasm about this technology. But the ability to mine the residual fly ash pollution created and dumped during the industrial era should get everyone's attention. Society can do more than paper over our historical environmental damage while continuing to build and expand a sustainable infrastructure. We can restore nature, clean up those dumps, and make cities and their suburbs greener. We can also clean up rural communities where a lot of this stuff was dumped in the past. It's fitting that the damage caused by coal-fired plants used to make Portland cement can now be repaired with a Roman invention, pozzolanic cement. Humans took a wrong turn 200 years ago in a variety of ways, but we don't need to be stuck with the pollution created during the industrial era. We can clean it up. We'll continue to track the low-carbon concrete story and keep you apprised of new developments. And by the way, Check out our recent Earth911 story about 3D printed concrete tiny homes in Texas. These houses can be printed in less than 2 days. And that means we can build a lot more small and extremely efficient homes for people in order to extend and to end homelessness. I hope you take a moment to share this podcast with your friends, your family, your coworkers. If you take a moment to write a review on your favorite podcast platform, it'll help your neighbors find us. And if you haven't subscribed, click that subscribe button now, folks. Join the conversation every time we're on the air. Please tell your friends, family, and the people you meet on the street that they can find us at Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the fine purveyors of podcast goodness out there that they prefer. Thank you, folks, for your support. I'm Mitch Ratcliffe. This is Earth911, and we will be back soon with another innovator interview. In the meantime, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.